Okay, so we are discussing linear equations in one variable, and in particular, we're discussing about the type of solution for a linear equation in one variable. We are discussing whether a linear equation has a unique solution, an infinite solution, or no solution. This seems to be the most difficult topic for SAT. Okay, but we have several examples here. We'll go through the examples, and then I hope you'll be able to catch up with the topic. All right. So Robin won't be joining for today. So let's get started. So we were discussing problem number 2, right? We were discussing problem sheet number 8, and we were on problem number 2. Okay. So I discussed the normal method to get the answer, but I told you there is one more way to get the answer. So that was about, so just read the question carefully once again. Read the question carefully once again. In the given equation, k is a constant. If the equation has no solution, what is the value of k? What is the value of k? Remember, you guys remember Anjali, Olivia, Prisha? You remember this question, right? We discussed this problem, and I told you there is one more way to arrive at the answer. You remember that? Did you try it out? Please give me a yes or no. Yes. See, listen carefully. So we have an equation. So this is an actual SAT question, okay? So we have 1/3 into y minus k is equal to ky. Gaurav, have you come across equations of this kind? These are called linear equations in one variable because we have just one variable y here, and you look at the power of the variable y. It's just 1. So that is why we call it a linear equation. All right, now it's not an issue. Okay, so we call this linear equations in one variable. Okay, we just have one variable y. K is not a variable. K is considered to be a constant. Okay, so we have 1/3 y minus 1/3 k is equal to ky. All right. So now your question asked about the equation being without any solution. There is no solution to this equation. There is no solution to this equation. So what is the condition? What is the condition? So if I have a general equation of the form ax plus b is equal to cx plus d, what is the condition for not having a solution? These two should be exactly the same, and these should not be equal. For example, if you have an equation of the form 2x plus 3 equal to 2x plus 5. If you have an equation of the form 2x plus 3 is equal to 2x plus 5, what can you observe? See, these two gets cancelled away. These two gets cancelled off for any value of x. Irrespective of the value of x, these two values will go away. Okay. Now you are left with a contradiction. Which means you can't solve this equation. Irrespective of the value of x you put, there is no solution to this equation. Got it? Irrespective of the value of x, there is no solution to this equation. So that happens when if you have an equation, general equation of this form, that happens when the coefficient of x on both sides are equal and the constants are not equal. Okay. That happens when a equal to c and B is not equal to D. We have already seen this in the previous class. So we are discussing a few problems on those. All right. Now, let's come to this question. So we have 1 by 3y minus 1 by 3k is equal to ky. All right. Now, you compare the coefficients of the variable being y. You compare the coefficients of variable on both sides. On LHS, it is 1 by 3, and on RHS, it is k. Okay. So your k value is 1 by 3. Now, if I try to go and substitute this value in the original equation, what happens? We have 1 by 3y minus 1 by 3 into k value is 1 by 3. Here also k value is 1 by 3. 1 by 3 into 1 by 3 is equal to 1 over 3 times y. Now, what happens to this equation? Look at this. We have y by 3 minus 1 by 9 is equal to y by 3. What happens to this equation? This is an equation without solution. Why? Because these two terms will get cancelled. Irrespective of the value of x, irrespective of the value of y, these two will get cancelled off. Okay. And you have a contradiction. Right? So there is no solution in this case. All right. So the value of k we are looking for is 1 by 3. So this is the approach we discussed in the previous class. Okay, this is the answer we got in the previous class. Remember? Anjali, Prisha, and Olivia. Remember, this was the answer we got in the previous class. The k value came out to be 1 by 3. And when you try and put the value of k in the equation, we know that it makes sense, right? Now the equation has no solution. So we are done, right? The value of k is going to be 1 by 3. And the alternate approach I was talking about was, I told you, see, in the previous class I have written it down. Write y in terms of k. From this expression, figure out the value of k for no solution. Let's try to do that. So we have our original equation as 1 by 3 times y minus k is equal to ky. Okay. Now, listen carefully. Please listen carefully. Now, let's forget about k. Let's assume that the k is some number, and let's try to find out the value of y. Of course, when you figure out the value of y, when you figure out the expression for y, there will be k appearing in the equation. Okay. So you take 3 to the other side. So we have y minus k is equal to 3ky. This is fine. I took 3 to the other side. I'm basically cross multiplying. So 3 goes to the other side because 3 is in the denominator on LHS. It goes to the other side. Right? Now what do you do? You bring the variable terms to one side. So variable terms are this one and this one. So you bring them both to, say, LHS. Let's bring everything to LHS. So of course you can move the other number to the other side. So you have y minus 3ky is equal to k. Now you take y outside as a common factor. So 1 minus 3k into y is equal to k. So our y comes out to be k divided by 1 minus 3k. K divided by 1 minus 3k. Is this fine? So in this approach, I was actually I was actually not worrying about k at all. I was actually trying to get the value y. I was trying to extract the value y. Okay. So of course the value of y came out as a expression in terms of k. Y came out as an expression in terms of k. Now tell me one thing. If this equation has no solution, y cannot have a solution, y cannot take a real value, what should be the value of k? What should happen to this expression? What should happen to the expression? Just think. We have y in terms of k here. Suppose, yes, very good. Yes, very good. What should happen? See, y came out as a fraction. Y is equal to k divided by 1 minus 3k. What happens when your fraction denominator becomes 0? Boom, right? When your denominator becomes 0, what happens? Right? There is no solution. Yes, it becomes undefined. Y becomes undefined because, see, you can't have 0 in the denominator, right? So we have answered that as well. So we put for no solution, we have 1 minus 3k is equal to 0. So 1 is equal to 3k, and your k value comes out as 1 by 3. So this is yet another approach. Cool. So this is the second approach. Of course, my point is, unlike an exam you are appearing in school, for a standard exam like SAT, you should know multiple approaches, because time is a huge factor. You get about 80 seconds to crack a question on an average. Some question you might be, you should be able to do it in maybe 20 or 30 seconds, because some questions will definitely take more than 80 seconds. So some question you should be able to do in a few seconds, actually, maybe 20 or 30 seconds. All right. And one more thing I wanted to highlight is, I know you guys are busy with school works and school assignments, but I told you it just take 1 hour. Okay, we are actually having classes for just 1 hour per week. Okay, now the assignments I will give you will also take hardly half an hour, right? So it's all together, say what, 1.5 hours of work. So please make sure that you do it consistently. You attend the lectures consistently. You do the assignments consistently, because consistency is the key. You're not running a 100-meter race. I again reiterate, we're not running a 100-meter race. We are running a marathon. So consistency is the key, because ultimately all this leads to a 3-hour exam, because we are training ourselves for a 3-hour exam. And specifically in mathematics, you have 80 minutes. Okay. So let's go to the next question. Let's take the next question. I see new guys today. Guys, we have already discussed the concept for these questions in the previous lectures, and these questions were given as assignments. So we are currently discussing those questions now. Okay. So in case you have any difficulties, do let me know. In case you're not able to figure out something, these are basic arithmetics we are doing. There's nothing like rocket science we are discussing here. In case you have any difficulties, do let me know. All right. Shall we go to the next question? Shall we go to the next question? Yes, question number 3. Please read up. Minus 4 plus kx plus 2x plus 3 times x plus 1. In the equation above, k is a constant. For what value of k does the equation have? No solution. No solution. So, of course, when you look at the RHS is not very simple, right? We have parenthesis. You have bracket to expand, and then you have like terms to combine. You have 2x, and then you see that there is 3x coming up. So you have like terms to combine, you have bracket to expand, and that's all. Okay. That's all. So let's do that first. So we have minus 4 plus kx is equal to, on RHS you see 2x plus 3 times x plus 1. So in the first step, what do? You expand the brackets. You have to use the distributive property of, yes, very good, 3x plus 3. And on the LHS, we have minus 4 plus kx. Cool. So we just combine the like terms. 2x plus 3x is going to be 5x. So we have 5x plus 3. In the LHS, we have minus 4 plus kx. Now, we have converted the question into the standard form. And standard form was, we have a linear expression in the LHS and a linear expression in the RHS. A linear expression will always look like ax plus b, or say 3x plus 2, 5x plus 3. These are all linear expression in one variable. So a linear equation will have an equality sign, and on both sides of the equality sign, you will have a linear expression. Okay, that is what we call a linear equation. These are linear expressions. So in a linear equation, you have an equation, and on both sides of the equation, you will have a linear expression. Now, this linear expression has no solutions. It has no solution. No solution. So what should be the case? 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 Yes, cool. Very cool. Cool. See, some of the coefficient has to be the same on both sides. That's great. And the constant is already different. So we are looking at a contradiction here. Okay. So in this case, the logic is very simple, right? Irrespective of the value of x you try to substitute, you're not going to get an answer. You're going to end up in trouble, irrespective of the value of x. You take any value of x, you can't get a solution, because when you try to equate the coefficient of x on both sides, what happens? When you make this 5x, what happens? The 5x term on both sides is going to get cancelled. Now you're left with a contradiction, right? So what should be the value of k? It has to be 5. Yes, very good. It has to be 5. What about others? Please let me know. So k is 5, so that the equation has no solution. Please let me know. For the new guys here, we are discussing. Yeah, Arya. Welcome to the class. I see Arya. I see Shubha, and I see Gaurav in the class. Welcome to this class. And as I just mentioned, we are discussing linear equations in one variable. So this is the first topic we have started with. So SAT has 4 major focus areas, and the first focus area is heart of algebra. In heart of algebra, we'll be discussing with linear equation in one variable, then linear inequalities in one variable, linear functions, and then linear equations in 2 variables, and linear inequalities in 2 variables. And we were discussing the first topic, linear equations in one variable. So we have seen different types of linear equations. Linear equation which can be solved in one single step, linear equation which can be solved in multiple steps, linear equation which needed simplification by expanding the brackets and combining the like terms, and all those we have seen so far. And this is one of the trickiest part of the SAT, where there will be unknown constants given in the question, and you will be able to figure out the value of the question according to the given condition. A linear equation can have a unique solution, it can have no solution, it can have infinitely many solutions. So these are the 3 cases we are discussing. We have already discussed the ideas in the previous class. Now we are on to solving problems. Okay, so I'll be discussing these questions one by one. The guys who are already with me have seen these questions. The assignment sheet was with them. So I believe that they have spent some time on these questions. But I will be definitely discussing these questions in detail. But the idea is you should be able to try these questions on your own. Okay. So let's go to the next question. We have 3 times z plus 1 is equal to minus half minus 5z. Which of the following best describes the solution set to the equation shown above? Please read the question, and if you have options given in the question, you should also try to read the options. And of course, irrespective of whether the question comes in calculator or non-calculator section, see, this is from non-calculator section, and of course this is not a good question. This is an MCQ. There is a mistake in this. There's a typing mistake. This is a non-calculator question. Even if it is from the calculator section, your first instinct should not be picking up the calculator, because we are racing against time here. Okay. MCQ stands for multiple choice question. There will be multiple choices given in the question. You have to pick one right answer. And GRD stands for grid type questions, where you have to plug in your answer. See, say in the previous question, the answer was 1 by 3. So we'll see the actual exam sheets later on. Okay, so there will be a grid in the exam paper, in the answer sheet. You have to plug in your answer as 1 over 3, or you can plug in your answer as 0.33, because 1 by 3 is 0.33, right? So there are 2 types of questions that will come for SAT. One is grid type question, where there will not be any options. You will get a numerical value as the answer, and which you have to plug in into the answer sheet. The second type question will be MCQs, which are multiple choice questions, where you have to pick an answer from the options, and you have to mark whether it is A, B, C, or D. You have to bubble the right answer. You have to bubble it using a pencil or a pen, right? Okay. In both sections, there will be 2 sections. One will have calculator. In one section you will be allowed to use calculator. In the second section, you will not be allowed to use calculators. But the idea is, it is also important when to pick up the calculator. You should know when to pick up the calculator and when not to pick up the calculator, because sometimes picking up the calculator, even if you are allowed to pick up a calculator, picking up a calculator is going to be a waste of time, right? So let's go to the next question. So we have in question number 4, we have 3 times z plus 1 is equal to minus half minus 5z. So we have 3z plus 3 is equal to minus half minus 5z, right? Yes. Now see this. See, we have 3 cases. We have 3 cases. We have 3 cases. This equation can either have a unique solution, no solution, or infinitely many solution. And when can you have infinitely many solution case? When LHS and RHS are exactly the same. Okay, the variable part and the constant part are exactly the same. For example, if you have something like 3x plus 2 is equal to 3x plus 2, see this case. See this case. In this case, it is always true. This expression is always true. So irrespective of the value of x you substituted this question, irrespective of the value of x you substitute in this question, this is always true. This is always true. This is always true. Always true. So we say this as infinitely many solutions. Infinitely many solutions. And suppose you have 3x plus 2 is equal to 3x plus 5. The coefficient part, the variable part is same, but the constants are different. Then we have a contradiction. We say no solution. Okay. And otherwise, in the third case, you will be happily able to solve this equation and come up with a unique value for the unknown quantity. So let's try to figure out so this is not this case and this is not this case. Okay. So we can figure out that there's a unique solution to this question. So the idea is bring the variable to one side, bring variables to one side, bring constant to the other side. So I'm going to bring this minus 5z to the other side. So this is going to be 3z plus 5z. I'm going to bring 3 to the other side. So it is going to be minus half minus 3. Class usually begins at 8 a.m. Indian time. And I don't know where you're from, but in Austin, Texas, it is 8:30 p.m. on Sundays. In CST, it's 8:30 p.m. on Sundays. So it is 8:30. It has been exactly 30 minutes since we started. It has been exactly 30 minutes. Now you can figure out, right? It's basically class timing is basically 8 a.m. to 9 a.m. on Mondays, Indian Standard Time. Okay. In Austin, Texas, the timing is 8:30 p.m. to 9:30 p.m. on Sundays. All right. So let's come back to the question. So what have we done? We have to bring the like terms to one side. We have 3z and 5z on one side, and we have the constants on the other side. So this is 8z, and on the RHS, you take minus outside so that it's easy for you to work out. So it's negation of half plus 3. It's negative of half plus 3. So this is minus of, so this is 1 plus 3 into 2 divided by 2. So this is minus of 7 by 2. 8z is equal to minus 7 by 2. So you bring a to the other side, it goes to the denominator. When you bring a to the other side, it goes to the denominator because you need to isolate the variable. So your z value comes out as minus 7 divided by 16. Your z value comes out as minus 7 divided by 16. This is all right? Okay for everyone? Please let me know. Please respond. Say yes, no, okay, good, bad, ugly, something. Because we just have this textual feedback. There's nothing else here. So do just let me know whether you're following or not. Cool. What about others? Which step? Arya, please do let me know which step you're stuck. This step is fine. This is fine. Oh, okay. See, here basically you know how to add fractions, right? How do you add fractions? Yeah. I'll come to that. I'll come to that. I hope you guys know how to add fractions. Yeah, basically, if you have to add half plus 3, it is half plus 3 divided by 1. And now you're looking at the common denominator. Okay, you're looking at the common denominator. So look at the denominators 2 and 1. Okay, now you should make a common denominator. Of course, for 2 and 1, we can consider 2, right? For 2 and 1, we can consider 2. So this term, I'm going to transform it as 3 into 2 divided by 1 into 2. Okay, so this is half plus 6 divided by 2. That is why we have 7 divided by 2. See, I guess you guys are used to doing stuff on calculator. But please understand, in an SAT, if you go and pick up the calculator, it will waste your time. So during the course of the program, try to do as many problems using your pen and paper. That is one thing. Secondly, as far as possible, try to do mental math. Okay, with practice over time, you will get used to that. The idea is, if you go and pick up an individual SAT question, it's not very difficult. If you have sufficient time, you can actually crack it. It's nothing beyond your school curriculum or something like that. It's not rocket science. They are not very difficult questions. But the idea is you're racing against time. You have only very few seconds to crack a question. So all these years, I assume that you have been using calculator. Here in India, it's not the case. Here in India, at least until end of grade 12, you're not able to, you can't use calculator. So kids here are used to doing things on pen and paper, and they can also do mental math to some extent. Okay. So speed is a factor here. So I would suggest when you're free, pick up some numericals and try to work it out using pen and paper. Try to work it out using mental math. Okay, it will give you some practice. And as and when we progress, it has been only about 10 classes or something like that. So as and when we progress, you will be able to do it quicker. Okay. But in case you're facing difficulties, do let me know. I am not exactly sure how you approach these kind of questions in school. So, but our approach should be trying to do the question as fast as possible. So that means in minimum number of steps. That means you have to skip some steps, which means you have to do some steps in your mind. Got it? Got the idea? See, I'll be writing down every step, but in case if I tend to skip some step, please do let me know. And one more request is you should also try to learn by skipping some steps, because you can't afford to write every single step in an SAT, because it's going to be time consuming. So as far as possible, try to reduce the number of steps. On the other hand, you should not make mistakes as well. Okay, you should not just hurry up with stuff and get wrong answer. That should not happen, because if you make a mistake, there is a possibility that your wrong answer shows up in the options. Okay, so this is fine. We have got the answer now. We have the answer ready. All right. Yes. So our answer is z is equal to minus 7 by 16, and that happens to be the unique solution. It is a unique solution. Cool. So this is our answer. Let's go to the next question. Problem number 5. We have 4x plus 1 is equal to minus lambda x. This is the Greek letter lambda. I hope you're familiar with. Minus lambda x minus 4. Okay. In the above equation, lambda is a constant. Which of the following values of lambda result in an equation with infinitely many solutions? And the options are 4, minus 4, 1, and no value of lambda. Yes. Let's try to see this question. We have 4x plus 1 is equal to minus 4x minus 4. Now, the question demands us to find the value of lambda so that the equation has infinitely many solutions. So just, you don't have to memorize any formula, okay? Just understand the logic. If you need infinitely many solutions, what do you need? You need identical expressions on both sides, right? If you need infinitely many solutions, you need identical expressions on both sides. Okay? You need identical expressions on both sides, right? That way, irrespective of the value of x you substitute, the equation will be true. Irrespective of the value of x, the equation will be true. Okay? So if you have 4x plus 1 on LHS, the expression on RHS should also be 4x plus 1. But tell me one thing, the constant is already different. The constant is already different. See, the constant is already different. Can you try and create an equation with infinite solution in this case? Is this even possible? Is this even possible? That's an interesting question. Is this even possible? Because you are looking at identical expression on both sides, on LHS and RHS. Of course, you can make this term identical. You can make this term identical by putting lambda is equal to minus 4. If you put lambda is equal to minus 4, what happens to this equation? This becomes minus of minus 4x, which is going to be 4x. Okay. So these two terms become identical, but the constants are not same. Constants are not same. Okay. So if you put lambda is equal to minus 4, what happens? This equation will have no solution. No solution. This equation will have no solution. This equation will have no solution, right? The equation will have no solution. Cool. No, if you put lambda is equal to minus 16, what happens? Somebody is telling me that you have to put lambda is equal to minus 16. Let's try and put lambda is equal to minus 16. When you put lambda is equal to minus 16, what happens? It becomes 16x minus 4. Even now, see, you don't have identical expressions on both sides. You don't have identical expressions on both. The variable term is different. The constant is also different. The numbers are different. The variable expression is different, right? So in this case, in fact, you will have a unique solution. In this case, you will have a unique solution because you bring yeah. Yeah, it will have a unique solution. That's true. Because, if you bring 4x to the other side and minus 4 to the other side, this is 12x and this is 5, and your x value comes out as 5 divided by 12. Others do let me know, because somebody has suggested me a value of lambda is equal to minus 16, and I have tried to substitute the value of lambda as minus 16 in this case, but that does not solve our problem. What happens to this equation? It has a unique solution. Okay, it has a unique solution. In the other case, when lambda is minus 4, what happens? It has no solution. Sorry, not this case. When you put lambda is equal to minus 4, what happens? 4x plus 1 becomes 4x minus 4. Here, there is no solution. No solution. Why? Why? It's a contradictory statement, right? 4x gets cancelled off, and you have 1 equal to minus 4. Okay. Yes. So, the idea is very clear. You keep trying different you try different values for lambda. You keep trying. You try and substitute different values for lambda. In one case, the equation has no solution, and that value being lambda is equal to minus 4, right? You understand that? You try and substitute different values for lambda. In one case, when lambda is equal to minus 4, the equation has no solution. Why? Because what happens? We have 4x plus 1 is equal to minus lambda x minus 4. If you put lambda is equal to minus 4, what happens? We have 4x plus 1 is equal to 4x minus 4. Yeah. In this case, these two will go away, and you are left with a contradictory statement. So we have no solution. Okay. And somebody suggested me lambda is equal to minus 16. And in this case, we have 4x plus 1 is equal to 16x minus 4. And what happens? We have 12x is equal to 5, and you have a unique value, unique solution. We have a unique solution. All right. Now, if you try other value of lambda, you're going to get a unique solution. Can you ever get a case with infinite solution? Can you ever get a value for lambda so that this equation will end up having infinite solution? That's my question. Please do respond. Others, please do participate, because I unfortunately have no other feedback. I just have to rely on your textual feedback. So please do respond. Please do let me know. These two cases are fine, right? These two observations are fine, right? You see, when you put lambda is equal to minus 16, what happens? You have a unique solution. Okay. Oh, you want to put 16. Let's try and put lambda is equal to 16. Let's try and put lambda is equal to 16. Let's try and put lambda is equal to 16. So we have 4x plus 1 is equal to minus 16 minus 4. Now what happens? in this case, we'll have a unique solution. Arya, it's not no solution because no solution case we have already seen. No solution case we have already seen. Okay. So we have 20x. Why 20x? Because it's 4x plus 16x is equal to minus 1 minus 4. So this is minus 5. We have 20x is equal to minus 5. So your x is minus 5 divided by 20, which is minus, just cancel off, minus 1 by 4. So in this case, you have a unique solution. In this case, we have a unique solution. Yes. What about value of minus 4? In this case, it has no solution. We have already seen that, right? Is that confusing? Is that confusing? Got it? Yes. See, that is why I discussed the general case in the previous class. See, a general case would look like this, right? The first case is when A is not equal to C. These coefficients are entirely different. Sorry. When these two coefficients are entirely different, you will always have a unique solution. You will always have a unique solution. Right? And in the second case, when the coefficients are same, A, C, and B is also same. The constants are also same. Now what happens? Both LHS and RHS are identical, and now you have infinite solutions. Okay, so that's a thumb rule. For infinite solution, you're looking at identical expression on both LHS and RHS. Okay, for no solution, you're looking at contradictory statements. No solution, you should have A equal to C and B not equal to D. In this case, the variable term will get cancelled because A is equal to C, right? So those two terms will get cancelled off. But these two are different. These two are different, given to be different. So in this, we'll have no solution. Yes. Cool. Yeah. So in our case, 4x plus 1 is equal to minus lambda x minus 4. Okay. Since these two are already different, you cannot vary lambda and get infinite solution case. Right? Because the constants are already different. You can't change them. The only value you can vary here is lambda, right? The other things are fixed numbers, 1 and minus 4. You can't touch them. So how much ever you try, you can't come up with a infinite solution case. Yes. And for lambda is equal to minus 4, you have no solution case. Why? Because this equation becomes 4x plus 1 is equal to 4x minus 4. So this is a contradiction. This is a contradictory statement. Okay. Which means no solution to this equation. Irrespective of the value of x, this statement will never be true. This statement will never be true. All right. So that is why we have no solution case. And for any other value of lambda, I mean, other than -4, you will have a unique solution. There will be a unique solution. Got it? You understood the question? Yes, cool. Now let's look at the options. And the question again, just read up the question again. They are asking for all the following values of lambda result in an equation with infinitely many solutions. Of course, no value of lambda will give you a case with infinitely many solutions. If the question was about no solution, the answer would have been -4, right? We have already seen that case. Yes. No solution. The answer would have been C. Yeah. Lambda is equal to -4 would have given you no solution case. Got it? Yeah. So it's pretty easy. I mean, you don't have to memorize anything. Okay, you just understand the logic. You know, these questions are one of the most tricky from this topic. Okay, this is one of the easiest topics. We are discussing about linear equations. We are discussing about linear equations in one variable. It's basically easiest of the easiest part, and in this part, this is the trickiest part. That's all. All right, so let's see the next question quickly. In the equation above, p is a constant. For what value of p, there are no solutions to the equation. So we have 4 times at plus x is equal to 3px. We have 4 times at plus x is equal to 3px. And they are asking for a case with no solution. So yes, very good. So we have brackets, parentheses showing up on LHS. So we expand the LHS first. We have 4 times 80 plus 4 times x is equal to 3px. Okay. So we have 320 plus 4x is equal to 3px. Of course, the constant on RHS is 0. All right. Now the constants are already different. For no solution, you just make sure that coefficients are the same. Right? See, the coefficients are same. If the coefficients are same, the x terms will get cancelled off. Okay, now you are left with a contradictory statement. If you try to make these two equal, you end up getting an equation 320 is equal to 0. Right? So what should be the value of p? The value of p should be chosen in such a way that the coefficients of x on both sides are exactly the same. Right? We just discussed this. Tell me you're clear with this? Right? Others. Please let me know if it's confusing. Also let me know. Do not hesitate. If it's confusing, do let me know. If you need further explanation, do let me know. I have no issues. No, cool. Prisha and Olivia, I hope it's you guys are with me. Yeah, cool. Yeah, so we have 4 is equal to 3p, and if you have 4 is equal to 3p, your p value is going to be 4 by 3. See, in this case, what are we trying to do? We are trying to make the coefficient of x on both sides. So what happens to this equation? 320 plus 4x is equal to 4x plus 0. So this equation is going to have no solutions. No solutions. All right? No solutions. So our p values 4 by 3. Gaurav and Shubha. Okay, I guess yes. Okay, Gaurav, yes. Cool. Right. So our answer to this question is, of course, 4 by 3. Okay, let's move on to a slightly more. I mean, it looks complicated, but it's not actually complicated because if you know the basic idea, we'll be able to crack it. Okay, so let's go to the next question quickly before we wind up. It's almost time. Let's crack this question and then we'll wind up. In this equation, read the question carefully. 8 minus 9 times z plus 1 is equal to alpha z plus 4. Alpha is a constant. Which of the following values of alpha does not result in an equation with exactly one solution? Exactly one solution means unique solution. So they are saying they don't need unique solution. You don't need unique solution. The value of alpha should be in such a way that there is no unique solution, right? So we have 8 minus 9 times z plus 1 is equal to alpha z plus 4. Can you try and figure it out just quickly? First of all, we have to expand the bracket on LHS. So this is going to be 9z minus 9 is equal to, on the RHS, it's going to be alpha z plus 4. Cool. Now you just combine this 8 and minus 9. 8 and minus 9, when you combine it, it's going to be minus 1, right? 8 minus minus 1. So we have minus 1 minus 9z is equal to alpha z plus 4. Right, so far so good. So far so good. We have just expanded the bracket on LHS. We have just combined the constants on LHS, and now we are left with an equation which is very familiar to all of us, which is, we are very familiar with this kind of equation. We have a linear expression on LHS. We have a linear expression on RHS. We are extremely happy to see this because, now you just have to follow the instruction given in the question. Let's see what is the instruction given in the question. You have to choose the value of alpha that will not generate a case with unique solution. Okay. So my first question is, can this have infinite solution? Can this have infinite solution? Can this have infinite solution? It's not possible because, for an infinite solution, think. You should have identical expression on both sides. Already the constants are different. We can't do anything about it. Because constants are already different. You can't generate identical expressions on both sides by just varying alpha. So this is not possible. Not right. Can you have no solution case? I'll just take 2 more minutes. Okay, just let's quickly finish this question and then we'll wind up. Can we have no solution? Can we have no solution? Yes, we can have no solution if we try to make the coefficients of the variables on both sides the same. If you make alpha is equal to -9, if you make alpha is equal to -9, this is going to give me no solution. Because, if you make the variable terms on both sides exactly the same, they will get cancelled off and you're left with -1 is equal to 4, which is a contradictory statement, right? So alpha is equal to -9 will generate no solution, and all other values of alpha will give you unique solution. All other values of alpha will give you a unique solution. Cool. So far, so good. Now you just need to look at the option and just get the right option. That's all. So far, so good. When alpha is equal to, there is no case corresponding to infinite solution. And for no solution, your alpha value has to be -9. And for all other values of alpha, you're going to get a unique solution. Because, an equation will either have a unique solution or no solution or infinite solution. There are no other possibilities. You just have 3 possibilities. Okay. So this case does not come. And this case comes only when alpha is -9. And so in all other cases, you have a unique solution. So let's see what is the right answer here. What is the right answer? Which of the value of which value of alpha does not result in an equation with one solution? So what is our answer? Everyone, please do let me know what is the right answer in this case. Please tell me what is the right answer. Yeah. Yes. So this case will give you no solution. This case will give you unique solution. This case will give you unique solution. This case will give you unique solution. And yeah, so we are winding up here, but please try substituting these values and verify that you are indeed getting a unique solution. Once this class is over, please try to substitute the value for 9. Alpha value is 9, 8 and -8, and see that it is indeed coming out to be a unique solution. All right. So we'll continue in the next class. So we have a few more problems left in this topic, and then we'll move on to the next topic in the next class. Okay. In the next class, we'll be discussing about linear equations, which can be converted to linear equations. Equation which does not look like linear equations, but with some simplification, they can be converted to linear equations. All right. See you then.